it feels in some way like Taproot is a bigger deal, but it's because we're taking it a lot more seriously, like even more seriously than we were taking things in the SegWit era. The stakes are higher.
Hello there, how are you all? Welcome to the What Bitcoin Did podcast, the number one Bitcoin podcast in Bedford, which is brought to you by Kraken, the best place to buy, sell and trade Bitcoin. I'm your host Peter McCormack, and today I've got Andrew Poelstra back on the show. He's going to give us an update on all the cool tech upgrades coming to Bitcoin. But before that, I have a message from my show sponsors. So first up, let's talk about the amazing BlockFi. They were just on the show a few days ago. I caught up with the team. I caught up with Zach and Flory to find out how they handled all the volatility during the recent crisis. And, you know, a lot of people have questioned their risk management, wondered how they would cope with it. Well, they put it all out in the podcast. They answered all the questions, so you should check that out. Anyway, they have crushed it this last couple of years. They have absolutely killed it and raised another 30 million to keep growing the company. Now, right now, they have their interest accounts, which lets you put your crypto to work and earn monthly interest payments with your Bitcoin. And they also have their crypto-backed loans, which allow you to access liquidity without selling by using your crypto as collateral. You can unlock up to 50% of the value of your assets in USD. And also this year, they've got a mobile app coming, and they've also got their Sats-backed credit card coming. They're going to smash it this year. And if you want to find out more, head over to blockfi.com, which is BLOCKFI.com. Let's also talk about Kraken, the best exchange in the world. They put the power in your hands to buy, sell, and trade Bitcoin now in these strange times when governments are printing unprecedented amounts of money. Many are considering Bitcoin as an insurance, and there is no better place to buy than with Kraken. At Kraken.com, it couldn't be easier to sign up and buy Bitcoin, and they also have a beautiful mobile-first app so you can buy Bitcoin on the go. With their world-class security, they are the most trusted exchange on the market. And with the 24/7, 365 customer support, they can help you out with any issues, whoever you are and wherever you are. There is no better place to trade Bitcoin. Find out more at Kraken.com or download the app, which is available for the iPhone and Android. Just search for Kraken Pro, which is KrakenPro. Okay, so on to the show today, and I have Blockstream Director of Research and my buddy Andrew Poelstra back on the show. It's been a while since I've covered some of the tech stuff, but I know some of you out there really enjoy this. If you haven't checked out my previous two shows with Andrew, they are highly recommended. Now, as you know, I am highly technical, so this was a very easy interview for me to do. No, I'm only kidding. You know I don't get this shit. But the Bitcoin protocol and the implication of things like Taproot and Schnorr signatures, it all goes over my head. But it's been a while since I've had a techie on. I know some of you like the tech stuff, so there's only one person to get back on. It had to be Andrew. I had to get Andrew to cover this stuff. Now, last time we spoke was in May in New York. We discussed Taproot and Schnorr signatures, and now nearly a year later, I thought it would be a good idea to get an update on these upgrades, what else he is working on, and what's coming next. Now, let's be honest, during this interview, most of the time, I've got literally no idea what he's talking about, yet Andrew has a way of explaining things that even I don't understand while keeping it fascinating. So if you techies out there, I hope you enjoy it. For you non-techies out there, you might enjoy this one too. If you do have any feedback on this show, you can get in touch. You can hit me up. My email address is hello@whatbitcoindid.com. And listen, I hope you're all surviving okay during this lockdown. Very strange times, lots of weird things happening. Starting to see some social unrest, which, you know, isn't pleasant. And I know some people are struggling financially. And listen, I've received a lot of emails, more than normal over this last couple of weeks. So listen, if you're bored, if you want to reach out, you got any questions, you just want someone to talk to, you can hit me up. I do reply to pretty much everyone. If you want to check out some other content, you can check out my other show, which is Defiance. That's available at defiance.news. My films are also there. I've got a couple of those out and another one which should be out in the next couple of days. Anyway, stay safe. Love you all. And if you want to reach out, it's hello@whatbitcoindid.com. Andrew, good morning. How are you?
Good morning, Peter. I'm doing pretty well. How are you?
Pretty good, thank you. This is our third time, but this time we have to be remote. We recorded about a year ago in Boston, and then we did another one in New York, but we're on a lockdown, man, so we've got to do this remotely.
Yep, exactly. I'm calling in from Austin, Texas, my home here, where I'm locked down, and I guess you're in London?
Wow, just outside of London, Little Bedford. I was there recently. I saw you, didn't I? I like
Yes, that's right. Yeah.
Yeah, I like Austin. How is Austin at the moment?
It's nice. It was stormy yesterday. It's sunny again. I think we're going to have on and off rain all week, which is nice. It's very green, actually. It's very pretty.
But
so nice.
What's the lockdown state?
Yeah, full. Same as a lot of places. All the bars are closed. All the restaurants are closed except takeout. Yeah, non-essential workers are either not working or working from home.
Right.
Yeah, the buses are cut down. The buses are free because the drivers don't want to take fares, but they're pretty much empty anyway. Yeah, so it's pretty much locked down.
That's interesting on the free fares, because we've had 15 transport workers in the UK die, and they think it's probably from the exchange of money is one of the potential risks, which was kind of interesting. Yeah. All right, man. Well, listen, look, I've been doing a lot of shows on the finance side of things and the libertarian response, and I've kind of neglected Bitcoin itself for a while. I don't really know what's going on in the tech. This is why I reached out to you. I thought it'd be good to do an update with you, and you can go through a whole bunch of shit that I don't fucking understand and explain it to me, like we've done the last couple of times. Because I've got no idea what's actually happening in the background. The first thing I wanted to talk to you about, actually, we've got a halving coming.
Yes.
What does that mean in terms of the protocol itself? Does it actually have any meaning at all? Is there anything that you, as a techie, as a developer, has to keep an eye on with regards to that?
So believe it or not, nothing at all. So this halvening takes us from 12.5 to 6.25. So I guess what does that make it? The third or the fourth halvening? Anyway, so the first one, maybe we were a little nervous about what was going to happen, right? Because it had never happened before. And then it went off technically without a hitch. Nobody had to update any software. There was nothing funny that happened. Nothing weird. Interestingly, actually, Bitcoin Cash, I think, just had a halvening, and they had no blocks for 2 hours after that. And we're not sure. I haven't heard too much about it. It could be just a coincidence, but it was kind of raised some eyebrows. But no, from a technical perspective, life just goes on as usual. There is a concern always that when the mining reward halves, because that is the bulk of the payment the miners get, maybe miners will go offline and blocks will slow down, which is possibly what happened to our Bitcoin Cash friends. But other than that, it's just part of the protocol. It's, as far as parts of the protocol go, it's a fairly simple one, and it's one that we've tested several times in real life. So,
well, we should talk about that. Because the difficulty adjustment is part of that. And somebody, I can't remember the interview now, somebody told me that is the most beautiful part of the Bitcoin protocol, is the difficulty adjustment. So I think for those people who don't understand this part of mining, do you want to explain why some of the hash rate might fall off, and then what the impact will be and what we will see?
Yeah, so sure. So that's a fascinating claim. This is the most beautiful part of what Bitcoin does. So briefly, the way that difficulty, or what difficulty is in Bitcoin, is a way of controlling how much work miners have to do on average to produce a block. So the way the blocks are produced, of course, is that miners are just trying very many hashes over and over and over again. They try a hash, they tweak the block by a tiny bit, they change a number called a knot. Then if the resulting hash is within some narrow target, then that's great, they get a block. If not, they just try again. So everybody's trying over and over and over again in parallel until somebody hits the target. And what the difficulty is well, it's inversely proportional to the size of the target. The higher the difficulty, the smaller the target, the more hashes you have to try. The lower the difficulty, the wider the target. And the way the difficulty is computed is that every 2 weeks, the protocol looks at the timestamps in the blocks. And I shouldn't say every 2 weeks, every 2016 blocks, which should be 2 weeks at 10 minutes a shot. The protocol looks at the timestamps in the blocks and says, did these last 2016 blocks take 2 weeks? If they took more than 2 weeks, then it decreases the difficulty, because it seemed like mining is too hard, so it should be easier. If they came in less than 2 weeks, it seemed like mining is too easy, it should be harder. So difficulty increases. And it does so in a linear fashion. Basically, it looks at the last 2 weeks of timestamps, says, oh, the blocks came in 10% too fast, so that's increased the difficulty by 10% to compensate. And then assuming nothing else changes, then next week we'll be roughly on target and we will actually hit that 2 week target. And that's how blocks wind up being spaced every 10 minutes, even though there's always miners coming online and going offline, and the price of Bitcoin changes, and all these things that otherwise would cause massive variances in the amount of hash power and in the rate of blocks. So what the difficulty adjustment does is all of a sudden, there's sort of a cliff. Every 4 years, roughly, there's a cliff where the amount of new coins that are minted just gets cut in half. Okay, so right now, every block a miner produces gives a miner 12.5 brand new Bitcoins, in addition to whatever transaction fees there are, which I think these days are somewhere between like half and a whole Bitcoin or something. So not a huge amount relative to the block reward, or the block subsidy, which is its creation of new coins. Then in a month or two, you might know better than me what the exact date is.
Mid-May, I think.
Mid-May. Okay, so yeah, we've got about a month to go. Cool.
Yeah.
All of a sudden, that 12.5 is going to drop to 6.25. And since the fees, as we mentioned, are still a fairly small proportion of that, more or less what's going to happen is that the income a miner makes per block goes in half. And that means that miners who are on the margin, who are producing all of these hashes, who are running these computations in the hopes of finding a block, suddenly the value of each of these individual hashes basically is cut in half. And if they're unable to pay for their electricity at half the income, which many miners might not be able to, they're just going to stop mining. So in theory, you could have a massive drop-off in hash power right after the halving if there's no compensating price action and if there are a lot of miners that are on the margin. And so what happens then is that for the next 2 weeks, we'll see blocks coming in very slowly because there aren't as many miners. There are only the high margin miners still running, and the miners who aren't able to shut down because they have electricity contracts or something like that. They're just going to keep running. And we'll see blocks produce very slowly. But then after 2 weeks are up, we have this difficulty adjustment, which will say, I keep saying after 2 weeks, I mean after 2016 blocks, which will be significantly more than 2 weeks. The difficulty adjustment algorithm will kick in. It'll say, hey, these blocks are being produced very slowly. We should reduce the difficulty to correspond to the new number of miners that are operating. And then blocks will return to their normal speed after that. And actually, because mining becomes a bit cheaper, maybe more people will come online, and we'll see a little bit of oscillation, but it will dampen out very quickly.
That's really interesting, that point on the 2016 blocks, because it is estimated a couple of weeks, but rightly, as you said, if the blocks are running quite slowly, it could be more than 2 weeks. So we could see some congestion in the blockchain for some time. Is there an ability to do an emergency difficulty adjustment? Is that something I've heard about before?
So the short answer is no. Okay. Is it possible? Yeah. So in principle, it's possible to do anything, right? The way Bitcoin works is ultimately Bitcoin is a social contract. Everybody has this software that for most people is Bitcoin Core, but there are other things out there. Everybody has this set of rules encoded in software which define what it means for a Bitcoin to be a Bitcoin, for a Bitcoin transaction to be a transaction, for a Bitcoin block to be a block, all this kind of stuff. And these rules include, among other things, the difficulty adjustment algorithm. They include the rules for what the difficulty means, for how many hashes on average people need to run through before they're going to get a block. And so in theory, if everybody agreed, they could just go ahead and change this. And they might change it to allow the difficulty to adjust more quickly, or allow an early detection of something like a massive hash power drop-off, or something like that. And we've seen some other blockchain systems try these things over the years. And there are two big categories of difficulties. One is the difficulty in deploying a sudden change to the software like that. Changing the difficulty algorithm would be a hard fork, meaning that if people upgrade, then they follow the new rules. And if they don't upgrade, then they keep following the old rules, and they're incompatible in both directions, meaning you would get a fork. There would actually be two separate blockchains with separate rules that had some shared history. All the coins would get split. If this happened accidentally or without prior preparation, there would be all sorts of crazy, messy consequences to that. And in practice, you wouldn't be able to deploy such a fork, certainly not with 1 month of notice. What would that look like, right? Somebody would write some code to change the difficulty algorithm. They would publish this on GitHub, or they'd publish it on the mailing list or something, or on Bitcoin Talk. And people would look at this and they just laugh. They say, like, we're not going to deploy a fork in the space of a month. That's not how Bitcoin works. It's not how Bitcoin ever worked. And I think no matter who did it, I mean, you could have like every famous Bitcoin person write a joint letter with like 100 signatures from everybody you've ever heard of, and it still wouldn't go anywhere. Like, people, just the way the Bitcoin community is and the way that Bitcoin users are, they just wouldn't go along with such a thing. So because Bitcoin is ultimately a social contract, and because the politics of Bitcoin are averse to sudden and dramatic and reckless and destructive changes, you wouldn't be able to deploy it. But then there's a second category of problems, right, which are more technical, where we've seen with a lot of other blockchains that try to do weird difficulty adjustments that really dramatic bad things happen to them. So this used to be, the most recent example is Bitcoin Cash, which interestingly seems to have come up with a difficulty adjustment algorithm, which is not too far out of the realm of reasonable algorithms, and which has worked fairly well for them. But historically, this has been a point of experimentation for different altcoins for a long time, since like 2011, 2010. People were talking about this. And people would come up with all sorts of crazy schemes, like the Komodo gravity well, and then crazy names like this. And they would deploy these difficulty adjustment algorithms. And what would happen is these coins would see massive hash power shocks. Like, their price would go down 5% in a day, and suddenly it would be more worthwhile to mine Bitcoin than to mine their coin. So then all the hash power would leave, and your hash rate would go like from a normal amount to zero, and then back multiple times in a day or multiple times in a week. And then these difficulty adjustment algorithms, by trying to measure the hash rate too quickly or with too few samples, would wildly overcompensate. And then suddenly it would be next to impossible to mine any blocks, or you'd have 1,000 blocks in a minute and you would fail to get consensus because you can't propagate blocks that quickly, or what have you. There are all sorts of crazy failure modes that happen when you try to mess with the difficulty adjustment. And where I think this comment you brought up about Bitcoin's difficulty adjustment being beautiful is that it's so conservative. It's not going to cause runaway oscillations, pretty much no matter what you do, no matter what happens with the hash rate. You're not going to get these wild runaway oscillations. It won't converge very quickly. It doesn't converge as quickly as it could if it were designed with fast convergence in mind, using all sorts of cool control theory and stuff like this that I don't really understand. But it will converge. It's very easy to understand, right? If the blocks are 10% too fast, increase the difficulty by 10%. And you aren't going to see crazy whiplash things. So I guess as a third comment, it's hard for me to see what event could happen to Bitcoin that would cause there to be any appetite for an emergency difficulty adjustment. Because unlike other blockchains, other altcoins out there, Bitcoin is not prone to seeing like all the hash power disappear at once, or to see some other much more important coin like Bitcoin just overwhelm the hash power of the system, so that you're just very much at the whims of high variance hash rate. Bitcoin is very stable relative to other systems by virtue of being the biggest, and also by virtue of having somewhat of a conservative culture and community. It's the biggest. We don't see these wild variances. And even if you did, Bitcoin's current difficulty adjustment algorithm, while being slow to react, would ultimately react in the correct way. So we'd see a few weeks or a few months of chaos, where chaos means the blocks are slower than you want them to be, so fees are a bit more expensive. It wouldn't be a big deal, and I can't imagine the relative chaos, and this is real chaos, of having some sort of fork, hard fork to a new difficulty adjustment algorithm that might have problems of its own. I can't see that happening.
Okay, so realistically, it's just a case. It's coming. We may have some congestion. It may slow down for a few weeks. We just need to prepare. We have to accept it, and what will be. But I guess it's just a waiting game then, right? It's going to be fascinating.
It really will be, yeah. Because the last couple of halvenings, we saw the price just ramped way up right before. And then the effect on miners' income was kind of zilch. And I don't know why this happened. It doesn't make any sense. and it doesn't make sense that it would happen again. Maybe some people are betting on it. I don't know, but there's no reason for that to happen, right? So this might be the first one where we actually see miners' income get cut by a whole lot. And you're right, we're just going to have to wait and see.
Fascinating. All right, man. Well, listen, what are you working on right now? What's keeping you busy?
So keeping on the Bitcoin theme for a bit. So I'm actually not doing, everything I do is ultimately Bitcoin. But what I've been working on a lot lately is kind of blue sky research. But something that's fairly close to reality is Miniscript. And I think I've talked to you about Miniscript before on your podcast. This has been around for a year or two. I'm not going to go too much into detail. It's basically a way to make Bitcoin script easier to reason about and to make all of the cool features of Bitcoin script accessible to people using ordinary wallets.
Is this something that Peter Willey is also working on? I'm sure he spoke to me about it.
Yep. Yeah, absolutely. So Miniscript is more or less Peter Willey's brainchild. It's Peter and myself and Sanket Kandlikar, who was an intern at Blockstream, who was I think he was an incredible intern who did like maybe half of the current Miniscript stuff. Was him and Peter working on the whiteboard. Maybe you did. Where?
So when I interviewed Peter, there was a guy, there was an intern in the room at the same time. I was like, yeah. So I got him on for like 5 or 10 minutes at the end of that interview, and he spent 5-10 minutes explaining what he'd been working on. I'm sure that's the same guy.
Yeah, I think it would be. Yeah, the timing works out. So so Miniscript is basically a way to template scripts so that you can use it. You don't have to be restricted to a bunch of specific, like, very restrained templates. There are a whole bunch of cool new features you can use, but now they're in a standard way where different wallets can interoperate with each other. They can do things like fee estimation. They can like jointly participate in multi-signatures and stuff and not have all these interoperability worries. So Miniscript itself has not changed since you last talked to Peter, or I should say it's changed in a couple of very small ways. Basically, renamed a couple of things to make them more compatible with existing code in Bitcoin Core. But what the exciting new development in Miniscript is that it is being merged. How do I want to describe this project? The way Bitcoin Core handles coins, the way that it identifies the coins that it owns in its wallet right now is kind of messy. It's sort of it started out with Satoshi, the original wallet, which used elliptic curve public keys to identify which coins were owned by the wallet. And the thing in Bitcoin, though, is that elliptic curve public keys are sort of one component of what goes into an address, one component of what goes into a script that identifies coins, but it's not the whole component. And so and initially there was kind of this one-to-one mapping, right? The way that you created an address was you literally took the public key, you put this in a script, which means you put a push public key opcode followed by the public key, followed by the check signature opcode. There's just those three components. And then you would encode that in some way and you would get an address out of that. And I'm talking like 2009, like 2010. And actually there was like pay to IP where you would connect to another computer and exchange a public key. And it was really hokey. And then we came up with the what we now call legacy addresses, where instead of having a whole public key, you actually hash it, you make it a little bit smaller, and then you reveal a whole public key later when you're spending. And so here's another way to think of public keys. And then we had, P2SH showed up. This is the 3 addresses, the ones that start with 3, where you could do multi-signatures, you could do slightly more complicated things. And now maybe here's yet another way that you have public keys. And then SegWit showed up. And we have these BC1 addresses, these BCH addresses that are encoded in best32. And here's yet another way that an EC public key might correspond to an address. And the way the Bitcoin Core wallet has worked the entire time is it's still using the public keys as identifiers, which means that conceptually it's a little bit of a mess, quite frankly. I could give you a legacy address that I generate with Bitcoin Core, and in principle, you could pop open that legacy address. you could re-encode it as a SegWit address, so which still has exactly the same public key, but it's a completely different address. Send coins to this new address, and my Bitcoin Core wallet will recognize it because all it's looking at is a public key. And so what that means is that you can send coins to an address that I never came up with, that I never gave you, and I'll still receive them. And as you might imagine, this could cause trouble if I'm trying to write accounting software or something around this. I'm going to see coins coming in that I can't quite identify the source of. I'm going to not see coins coming into the original address. Like, you'll say that you paid, you'll be able to like prove that you paid, but I won't be able to see the proof. And it's just a complicated situation. And the reason that this has happened is because it's all been sort of an outgrowth of the original Satoshi public key based wallet design, where as Bitcoin has grown and become more featureful, things have been sort of hacked onto that. So there is a new scheme called descriptors that was developed by Peter Wolla and now Andrew Chow. And this originated a week maybe before Miniscript. There's actually this wonderful kind of coincidence of ideas. The idea behind descriptors is, rather than starting with a public key, you actually encode what an address is. If you're using P2SH, you say P2SH. If you're using a legacy address, you have, I think you say PK or PKH or whatever is the encoding for legacy addresses. If you're using SegWit, you use WPKH for SegWit addresses, and so on. And then you put your key. So you have was literally a text file where you have your key encoded, and this public key, it might be just a straight up public key. It could be like a BIP32 path that describes how to compute the public key. It could be, I think those are the two things right now, but there are a couple more things we're going to extend this with. Basically, you write out your public key in a way that tells the Bitcoin Core wallet how to compute that public key, or how to find it, or like which hardware wallet it needs to go ask to get the key. And you also tell it how that key is encoded in the blockchain. Are we using a SegWit address? Are we using a legacy address? Are we using whatever? And so what's cool, I'm going to bring this back into Miniscript now, is that the text encoding for these descriptors and the text encoding for Miniscript are designed to fit together. And so what this means is that rather than going from the Satoshi thing where we've just got one key and it's a free-for-all, descriptors bring us some structure on that, where now we have a key and we're also specifying how to use that key and how to encode that on the blockchain and which actual address was produced. And then with Miniscript, we can even abstract over keys and say, rather than looking at how keys are used, let's look at how scripts are used. Let's have multiple keys. Let's do multi-signatures. Let's do time locks. Let's do hash premages, all this cool stuff. And so when we're going to start seeing Miniscript used is basically after Bitcoin Core supports descriptors and then extends descriptors to include Miniscript. And on the descriptor front, we are rounding the bend. You probably have to ask Peter or Andrew Chow for real timelines here. But Andrew has been working on implementing descriptors in Bitcoin Core and actually overhauling the wallet code, which has been a tremendous undertaking. That's taken the last, I guess, like, depending how you measure it, like 12 to 24 months. And we're finally starting to round the bend on that. Like, we're nearing completion of the descriptor wallet overhaul. And once we have descriptor wallets, aside from the Bitcoin Core wallet suddenly being, in my opinion, like a real wallet that I'd be willing to put money in, which I wouldn't now, we'll also have the ability to deploy Miniscript within Core. And then all of these cool benefits of Miniscript I've been talking about, we get interoperability, we get new features, blah, 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 blah. Suddenly those are really in users' hands because Bitcoin Core, which is the most popular wallet, or the most popular self-custody wallet, will have support for that. So that's been a lot of exciting development. Jumping topics quite a bit. Another exciting thing in Bitcoin is Taproot.
Well, let's go back to that Miniscript thing, because anyone, look, I'm going to let you into the secret. I'm not very technical, Andrew. I'm not.
Oh wow, I can tell.
So most of that, I had no idea what you were talking about. The odd word came up where I'd be like, oh yeah, SegWit, I know what SegWit is, a little bit. But what does it actually mean? So what does this mean for you as a developer? And what does that mean for a Bitcoiner like me who just holds Bitcoin, buys Bitcoin, uses it for things? Does it actually mean anything for me? Will I see any difference? Or does it just make your life easier?
Yeah, absolutely. So let me answer the developer question first, because that's actually a fairly simple question. So as a developer, I often find myself writing my own special purpose Bitcoin wallets for various one-off projects because maybe Core doesn't quite do what I want, or Green doesn't do what I want, or whatever my personal wallet is. It doesn't do coin selection in a way that I want to do. It doesn't do fee computation. It doesn't chain transactions or whatever, blah, blah, blah.
Yeah, I'm the same. I wrote one this morning.
Right. Yeah. I mean, like pretty much every day I wake up and I think, how do I want to use Bitcoin today? And I write a new wallet software to use Bitcoin in that way. And this is very meditative for me. This is how I hone my powers. And so what Miniscript does for me there is there's a whole bunch of really awful, fiddly, temperamental shit that you have to do to write a wallet, where you have to estimate for all the coins that you're holding how large a transaction might be that spends those coins. You have to figure out where the signatures go. If you're using a weird script, maybe they appear in a certain order, or maybe there's extra like filler stuff that you have to put between the signatures. I have to think about how to, I need those sizes so that I can estimate my fees, right? If I'm going to, the fee is proportional to the size of the transaction. If my wallet is going to interoperate with other systems using the same wallet or using, God forbid, different wallets, there's a whole ball of wax there. And so Miniscript lets me abstract all of that away. I have a library called the Rust Miniscript and the Rust programming language. I just use that library and it solves all those fiddly problems for me. So I can actually focus on the business logic that I'm trying to implement into this wallet. So as a developer, it saves me a lot of very repetitive and fiddly work that is really, it's just really fiddly. There's all these like off by one errors you can get. There's all this like counting, like you break apart a transaction into like 50 different parts and like count up the bytes in every one. It's horrible. Then as a user though, what does this mean for you? What does this mean for me? So I can tell you something that bothers me and probably bothers you is a concern when you hold Bitcoins. If you own your own Bitcoins, chances are your coins are spread across a number of addresses. And every address has some public key associated to it, just like a single public key. And then maybe these are all derived from a BIP32 seed or something. Maybe you have like a crypto steel or a titanium plate or whatever. You might have this encoded as seed, but ultimately all of your coins are controlled by single public keys. And if you lose those public keys, then you will never get your coins back. And if you lose a seed, if you lose the private part, then you will never get your coins back. And if somebody finds that key material, that secret key material, they'll be able to steal your coins and you will never get your coins back. And if you die or have amnesia or like suffer a brain injury or something and are no longer able to access this secret key material, then you will never get your coins back. And if your software becomes unmaintained and you weren't using a very popular standard and there are no longer software that can decode the secret data, then you will never get your coins back. And this is all very uncomfortable, I think, as a Bitcoin user. I've got a couple Bitcoins somewhere or other that are stored basically in this fashion, where basically if anything happens to me, or if the wallet that I wrote this morning, I no longer feel like maintaining, which has happened to every single wallet I've written, by the way. This is constantly happening to me, and then I have to go back and read the code whenever I want to spend them. It's a very fragile situation. And what I would like, first of all, I would like to have a multi-signature solution. I would like to have, rather than one single key, have multiple keys. So maybe have like 5 keys, and any 3 of them brought together are able to spend the coins. And this is something that there are actually several solutions out there, and there are various services. There are companies that will be a countersigner for you, and that will hold keys for you. So just adding multi-signatures is kind of a solved problem. And I say kind of because while this is completely solved, these different multi-signature services are still behaving in kind of a ad hoc and I guess just ad hoc is what I want to say. So if the service that you're using goes out of business or something, you'll have their software and you'll be able to recover your coins by whatever recovery mechanism they happen to have. But in general, you're going to have to move your coins, right? Because they went to waste and now you need to move the coins. And hopefully there's somebody who has written software to allow that kind of recovery to happen, which there will be, of course, with anything remotely widely used, but it's still kind of an ad hoc situation. So that's one thing. You want to have multi-signatures. But then another thing that I would like to have for my own coins is some sort of dead man switch, where if I don't move my coins for 6 months or for 12 months or something, I would prefer if the coins then transferred from my control, because presumably I have lost my keys or something if I'm not moving the coins ever, to some alternate set of keys. And maybe that alternate set is held by like my parents or my lawyer or something like that. And so I'll still have a recovery mechanism. And to the best of my knowledge, there are no services out there that offer this kind of recovery mechanism. And the reason is that when you go, even going from single keys to multi-signatures, in the absence of Miniscript requires that you hire some people who really know Bitcoin script and who know how to do weird things with Bitcoin. Going from multi-signatures to these sort of various conditions, where at time 0 you have a certain set of keys, and then at time 6 months you have a different set of keys, and maybe at time 12 months you have yet another set of keys. Now the technical requirements are much higher, and it's not only the technical requirements for just coming up with a script that does this, which Miniscript solves. It's also the technical requirements for how do you estimate fees and how do you produce transactions, which Miniscript solves. And then also the technical requirements of how do you make this work with various hardware wallets. If you've got a multi-signature setup, how do you make sure that whatever software that your user is using is going to work with your complicated multi-signature with counterfactual setup? And that last problem is something that kind of works for multi-signatures, because everybody likes multi-signatures, and there's only, at least for a small number of keys, there's only really one way to do multi-signatures, and kind of everybody has some way of supporting it, including Core, including Treasure and Ledger and Coldcard and all the popular hardware wallets, and Electrum and Armory and all that good stuff. As soon as you get into complicated scripts, you lose that interoperability. So suddenly your service provider is going to have to write their own special purpose software, and you, to use a service provider, are going to have to use their software instead of using Bitcoin Core or Electrum or whatever you normally be using. And as a user, that's pretty scary, and I wouldn't go for it. And I think most people who are conscientious enough or wealthy enough to want this kind of service are also not going to want to take that risk. So as a result, it's not a good business proposition, right? You're creating a business that requires you hire a bunch of very expensive experts to produce a product that people don't quite understand that they want, and the people who do understand they want won't use it. I mean, what are you doing? So what Miniscript will do is solve all of the problems that I just listed. It will not only solve your technical problems for you, so you can get away with fewer experts, or maybe less time from your experts. It will also solve the interoperability issues, which are the reason that people are kind of hesitant to use this in the first place. And as a kind of side effect of solving the interoperability issues, not only do you let your users use their own wallets, it also means that if you go out of business or your software becomes unmaintained or something crazy like that, then there is a way for your users to recover their coins, right? Because if I have a dead man switch that activates in a year or in several years or whatever, and by the time it actually activates, nobody remembers how to use it, like what have I accomplished, right? So Miniscript, by virtue of being a standard that covers all of the different use cases I'm talking about, makes this possible. So once we have Miniscript deployed in Core and in a few other places, then I'll actually be able to do this kind of crazy dead man switch schemes that I have been planning, but have yet not done it for many years right now. So just so you know, Yeah, I shouldn't say this in public, but if you kill me, my Bitcoins will just disappear. There's no way to recover them right now.
Wow. But that's not good.
Yeah. No, it's really not. I mean, I won't mind so much, but certainly.
Someone will.
Certainly, yeah, somebody will, yes.
Next up, I talked to Andrew more about Taproot, Schnorr, and Bitcoin tech. But before that, I have a message from my amazing sponsors who I could not make this show without. So I've got a new sponsor. They've been on the show for a few weeks now. You will have heard me talk about them. It's sportsbet.io. We recently had a poker tournament which they sponsored, over 1 Bitcoin in prizes, and over 500 people registered. I'm going to badger them soon. We're going to do another one because that was amazing. Now, you should know who sportsbet.io are. They are the company that put the Bitcoin logo on a Premier League shirt. Yes, Watford FC in the Premier League, and they invited me to go and see them play. I saw them draw with Tottenham, which was disappointing because I wanted Tottenham to lose. And then I saw them beat Liverpool's only defeat of the season, which was obviously devastating for me. But they wanted to support the show. They wanted to sponsor it. And even though we have this coronavirus lockdown, they were like, Pete, we're still doing it. So big thanks to the team over at sportsbet.io. Now, if you want to check it out, I've signed up. I've had a play. They do have sports betting available there. They've got Russian ping pong, but they've also got markets for esports, including eFIFA, as well as their Bitcoin casino and my fave, the poker room. They've got loads of promotions that are available at sportsbet.io/promotions. But if you want to find out more, do head over to the website. It is sportsbet.io. That's sportsbet.io. And lastly today is CoinTracker, and they've got a couple of shows left. So let's give them a final boost before their sponsorship ends. Now, I did get some shit for having these on originally. I had some people saying, why are you having a tax company on? Tax is evil. This isn't Bitcoin. Look, I get it. I don't want to pay tax, but I also don't want to go to jail. So I pay my tax. And calculating Bitcoin and crypto taxes, it's a pain in the ass, man. There are so many lines to do. It's very complicated. And to be honest, I probably wouldn't be able to do it without these guys. So I set myself up on their website. I became a customer. I set up my wallets on my exchanges and pressed the button. In less than 2 minutes, I had my taxes calculated straight off to my accountant. Job done. Now, they do have filings which work in the US, UK, Canada, and Australia. It's free for users who have 200 or fewer transactions. If you are one of those crazy traders who's got thousands of transactions, though, you can get a 10% discount. You just need to use the link cointracker.io/A/WBD. It is available on the web. They do also have an app which is available in the Apple and Android app stores. But if you do want to find out more, head over to cointracker.io, which is cointracker.io. All right, so listen, the first time we met was, actually prior to us meeting, I sat down to watch your presentation about Schnorr signatures in Boston. Do you remember that, at the expo? And
yes.
That was about 2 hours before we did the interview, and I watched that presentation, and I was like, shit, what are we going to talk about? And then we made that show that everybody loved. Everybody loved that show, and it was good fun. But this is important stuff right now, right?
Yes.
The Schnorr stuff. This is related to Taproot, yeah? Yep.
This is related to Taproot.
So you're going to have to go through this. Update us. Explain again to people what Taproot is, firstly, and then talk to us about the progress that's being made.
Yep. So Taproot, on a high level, is actually very simple. When I've been talking about Miniscript, I'm talking about Bitcoin scripts, so that you do all of these cool multi-signatures or time locks or hash locks or different ifs, thens, and alternatives and blah, blah, blah. The idea behind Taproot is usually your coins are controlled ultimately by one public key. This is the original Satoshi's vision, right? For one public key, one coin. There's just one public key that controls the coins, and that corresponds to one user. But then it turns out there are actually many other cases. It doesn't have to just be one user where there's one public key. If you have a multi-signature, you've got 3 people who all want to simultaneously sign, there's a way that they can produce one public key that represents all of them, and then they interactively do some protocol, and they wind up with a signature. And you can do more interesting things. You can do thresholds. You can do various complicated signing structures and blah, 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 and whatever. But the upshot is that the vast majority of coins in Bitcoin, even ones that aren't normal single key wallets, could actually have their spending conditions represented by one key. And the only time that you need to use Bitcoin script is in the case of weird things like this dead man switch, or in the case of a non-cooperative close in Lightning, or in the case of atomic swaps where somebody has to reveal a hash pre-image or something like that. And so what Taproot does is it says, let's circle way back to the original public key scheme for holding coins. Let's stop hashing things and let's stop, just encoding them in scripts. Let's just throw a public key there. So you have a public key. But here's the thing, we still need scripts, of course. There's a reason that we have all this scripting mechanism. So what Taproot does is it lets you tweak your public key in a way that it cryptographically commits to a script, but continues to be a public key. It continues to be a key that somebody can sign for. And in fact, the same people can sign for it. If I have a public key that I can sign for, I can tweak it using the Taproot mechanism, and I will still be able to sign for it. I just get like a slightly different public key. And what's cool about this is now I can go throw that on the blockchain. And the blockchain will see there's a public key. If I spend the coins by signing with that public key, that will just work. And nobody will even know that I did this tweak. I'll have a script committed in there, but nobody will even know that it existed. But if I find that I do need this script because, say, my original keys were lost and I need to use a dead man switch alternative or something like this, at that point, I can go to the blockchain. I can provide what's called a witness. I can prove that actually this public key committed to some alternate script. I provide the new script, and then I satisfy the script with whatever my alternate keys were or whatever. And so I get all of the benefits of Bitcoin's scripting system, but unless I actually need to use them, I don't reveal them to the blockchain. I don't even reveal that I was using a script. And this, of course, improves scalability. The less things I reveal to the blockchain, the less things people have to verify. And it also improved my privacy. Because now, even though I'm doing something complicated and uncommon, I have my coins stored in just what appear to be ordinary public keys, the same as people using a Bitcoin Core wallet, and the same as people using some sort of multi-signature wallet. And in fact, the same as people using pretty much any wallet scheme that's out there. Even Lightning payment channels, assuming cooperative closes, are going to look identical to anything else. Everything's just one public key. One public key, one signature. So that's what Taproot is. The core premise of Taproot is this trick where you take a public key and you're able to commit to some data. And what we're using this for is to commit to a script. And the idea is that usually, overwhelmingly frequently, the script will never be used, so it never gets revealed. Okay, so that basic premise more or less has not changed in the years that we've been talking about this. There has been a fair bit of detailed design iteration on Taproot that is very valuable, but most of it's a bit too technical to get into here. And then there has been a whole bunch of both outreach and implementation that's happened since we've last talked. So on the outreach front, there is an entity called Bitcoin OpTech, which is a sort of a group of people who have been working on messaging between large entities like corporations and businesses. They don't have to be big, just anybody trying to use Bitcoin in an institutional setting, and people doing Bitcoin protocol development and people doing wallet development, and trying to bridge the communication gap here and make Bitcoin possible to use for institutional people. And the Bitcoin OpTech folks, Mike Schmidt, John Newberry, and then like several others who I'm just not going to name, put together a series of workshops on Taproot using these what are called Jupyter notebooks, these sort of interactive Python scripts, where people were able to show up for these workshops. We've had a few, and there was just one in London recently at Advancing Bitcoin. There was one in New York that I attended alongside a conference that I'm blanking on which conference it was. There was one in San Francisco that I wasn't able to go to. And this lets people figure out how to use Taproot, actually go through how some of the cryptography is constructed. We got a lot of really valuable feedback from people doing this. So alongside all of these sessions, we had an IRC channel open where Peter and I and Andrew Chow and all of the people, Johnson Lau, all the people working on development were able to talk to people actually trying to use Taproot and get a feel for where the pain points were, get a feel for what questions people had, get a feel for what concerns people had. And we were able to update the design and also update our BIPs, our write-ups and our rationale and our proofs to reflect all of these things. So that's been awesome. And that was really absolutely spectacular. The first time I went to one of these sessions, I was just blown away at how well put together this all was. It was really, it was really great. And then on the implementation side, we've written a whole lot of code. When I say we, I don't actually mean me. I mean, not me. Peter Willa, of course, as always, Andrew Chow, Jonas Nick, Tim Ruffing. Greg Maxwell even pops his head up and contributes from time to time, which is nice. He's been mostly laying low for the last couple of years, but he's alive, and sometimes he reaches out. So there is a branch of Bitcoin Core. I don't think it's a pull request. It's the private branch on Peter's repo that has Taproot implemented. And there is a reference implementation of all of the Taproot code and the derivations and stuff that are in Python and I think a couple other languages. There are a whole bunch of test vectors that people have produced to poke at various aspects, at the various possible ways to spend coins and the various possible ways to create addresses. So all of that implementation work has been done, and it's been like, as we iterate on the design, I mentioned there have been a few technical changes that we made, and all of those technical changes, of course, required redoing all the test vectors and tweaking a bunch of things and so forth. So that's on the Taproot side. That's sort of on the verification, on the consensus code, on what actually would go into Bitcoin Core nodes to verify Taproot outputs. But there's a whole nother half of this, which is the signing side, which is if I have coins controlled by one of these Taproot outputs, how do I actually spend them? And this brings us into the second thing that you mentioned, which is Schnorr signatures. So this is sort of how Schnorr signatures and Taproot are related, right? Taproot is this new Bitcoin output type that comes with new rules for validation and new scalability and privacy benefits. Schnorr signatures are the digital signature mechanism that Taproot uses. And what Schnorr signatures get you is the ability to have a single public key that represents a whole bunch of different signers, or a single public key that represents an atomic swap, or a lightning payment channel, or something like this. The current Bitcoin scheme uses an alternative to Schnorr signatures called ECDSA.
Yeah, I remember that from my last one. And that was to do with the that Schnorr signatures had like a 50-year... Was it like a patent?
Not 50. It's 18. I think it was an 18-year patent.
Is it 18 years? I thought it was 50 years.
Yep. No, it's from 1990 to 2008, I believe, was the lifetime of the patent. So ECDSA was developed in response to this patent. And ECDSA is remarkably similar to Schnorr in spirit. But on the algebraic level, on the technical level, it differs from Schnorr in a couple important respects. And the result of these changes is that a lot of the cool multi-party things I've been talking about are very difficult to do with ECDSA. They require much heavier crypto. They're much slower. They might require new assumptions. They might require multiple rounds of interaction, whereas Schnorr would require much fewer rounds of interaction. It's harder to understand this stuff. It's harder to implement it. It's harder to review it. As a consequence, more or less, nobody has ever deployed, certainly not in a production setting, nobody has deployed ECDSA multi-signatures. Although I understand there are a few people working on this. As people get impatient with the Taproot deployment timeline, people are trying to do this with ECDSA, but you can tell it's much slower and more complicated and more fragile because of it. So Schnorr signatures are, from a user perspective, is really just this minor component where we're swapping out the ECDSA component for the Schnorr component. And as a result, there's basically no changes. But from a development standpoint and a functionality standpoint, suddenly a lot of cool things that were previously kind of very theoretical or very inefficient things become possible. And importantly, the most important one, of course, is these multi-signatures, where you have one key that represents multiple signers, and they just interactively produce signatures whenever they together want to spend coins. So on the Schnorr signature side, or on the multi-signature side, there has been quite a bit of development. I'm trying to think. I guess the last time we talked would have been after that the talk at the MIT Bitcoin Expo, which I guess was over a year ago now.
No, last time we talked was after we got into bed together in New York.
That's right.
In your
That's right. At
hotel room.
Consensus.
Yeah.
I always forget. I go to the Consensus conference in New York. There's all these suits. There's so much money everywhere. There's so much coke. It's hard for me to remember sometimes who all I get into bed with. But you're right. That was the last time.
Let me just ask you another couple of things on Taproot. The first thing, again, it's the same question as before. For me as a front-end user who never digs into the tech too much because I don't understand it, again, how will it affect me? Or is it just something that will happen in the background and I won't notice a difference?
Yeah, that's correct. Yeah, you won't...
Cool. Yeah, I should have just said that. I should ask that at the start. Okay, but let me ask you another thing. This is a major change, right? This is not an insignificant change. Do you get nervous about a change like this, different from any other change? I mean, do you and the other guys, when you're talking about it, are you nervous about this at all?
So, believe it or not, no. What's very interesting to me is that this change, in terms of scope, is much, much smaller than SegWit was. And the reason I say that is that Taproot provides a new output type. It means it's not a new address type because SegWit introduced a new address type that was future compatible with this new version. But it's a new output type. It's a new way of storing coins that wallets can choose to support. And what that means is that all of the risk inherent in Taproot is limited to these new outputs. It's limited to the people who want to use them, who are able to deploy and do testing and stuff on their own schedules. And then the consensus part, that the nodes validating all the new code, when they see these new outputs, they need to validate those new outputs, of course, but they don't need to do anything more than that. So with SegWit was kind of terrifying because SegWit changed the transaction format to introduce this new witness field. So on the peer-to-peer layer, when people were transmitting transactions around, there was this negotiation that had to happen to decide which transaction format was supposed to be used. There was change in the size of transaction as measured by legacy nodes versus as measured by upgraded nodes. There was change in the format and the weighting of blocks. There was a change from the pre-SegWit model, where if you tweaked any part of a transaction, including like stuff like the signatures, then it would change the TXID, which is bad. This causes malleability. This causes all sorts of problems. Then SegWit introduced this witness field, where if you change the witness field, then the transaction ID doesn't change. And then this makes it a little bit difficult sometimes. If you see the same transaction with two different witnesses floating around, how do you deal with that on the peer-to-peer layer? There are all these like really complicated logistical questions, and it affected every part of the Bitcoin consensus protocol. It's just terrifying. It's a miracle that the SegWit was implemented and deployed as well as it was, and that nothing awful happened. It was kind of terrifying. Even aside from all of the messaging and fear mongering and all of that about SegWit, independent of all that, because that was all the stuff that you read in the news during the SegWit time was for the most part just technically bankrupt. Like it was these were not real. There was no meaningful opposition to SegWit that you heard about in the news that people were shouting about and stuff. But there really were reasons to be scared of that level of change, and that was reflected in the amount of testing and QA and the tremendous amount of time that went into developing and implementing SegWit. Taproot, to contrast, is much narrower. It doesn't introduce, so we've made a lot of efforts to minimize the number of new things that are happening, even within this output type. We have no new cryptographic assumptions. Okay, we're using Schnorr instead of ECDSA, but we're using the same elliptic curve, we're using the same hashes, we're using the same kind of Merkle trees. We are simplifying some things, we're making some things more robust versus the way these were designed in other parts of Bitcoin. But ultimately, it's all the same stuff. It's just we've taken the lessons that we've learned, which for the most part are just fairly narrow, minor technical things, and we're putting those into Taproot. And then it's limited to just its new output type. It doesn't change the peer-to-peer layer. It doesn't change the way blocks are formatted or transactions are formatted. It doesn't change the address format. Basically, all the software that we're using today will continue to work in exactly the same way after Taproot is deployed. So for that reason, Taproot doesn't scare me at all.
It's a breeze.
What's interesting is that the Bitcoin community demands an even higher standard of reassurance than it did back in the SegWit era. So the kind of arguments that we're making to argue security and to argue that this is actually a simple change and that it's just the least risky thing we could be doing, there's a lot more work that goes into this. We have some published papers related to this. We have mathematical arguments of security of the new crypto constructions, even as narrow as they are. And even though there's stuff that's been deployed, we have arguments for security. We have a lot more eyes on this code and on this design. It was amazing what the Optech folks put together. When they did this first workshop, I remember they were expecting to get 20 or 30 people to sign up for it, and they got, I think, over 150, just like different developers working on the Bitcoin protocol and working on wallet stuff who wanted to learn about Taproot. So we got a tremendous amount of feedback from a very diverse crowd, which was great. So it feels in some way like Taproot is a bigger deal, but it's because we're taking it a lot more seriously, like even more seriously than we were taking things in the SegWit era. The stakes are higher, right? Bitcoin's worth more, it's more firmly entrenched. It's not just the price, of course. The price is maybe the least important thing. Bitcoin's much more entrenched. We're seeing like large institutional players looking at it. We have a lot of people. We have like a generation of people who grew up, who became software developers, who became cryptographers with Bitcoin. I know a lot of people for whom Bitcoin has been their entire career. And we're a lot more conservative about how we deploy changes like this.
All right. So there's a lot of stuff happening that's going to make your lives better in terms of a protocol developer. So anyone who's a protocol developer is going to be very happy with what's coming. And also it's going to make Bitcoin itself more efficient, right? It's going to make it better. But in terms of a normal user like me, all this stuff's going to happen, and I'm going to blindly not know any difference. I'm not going to notice any of this amazing hard work you've all done, which seems a little bit unfair.
It is a little bit unfair. So a couple things though that you will notice. So what you will notice actually is that the fee pressure is going to go down. A consequence of the scalability improvements that come with Taproot, a consequence of having one key, one signature for pretty much every coin, is that the size of your transactions and therefore the amount of weight that you have to pay for as part of the block is going to go down. So fees will be a little bit cheaper. Another thing that you will notice is that because it will be possible to do multi-signature stuff in this more efficient way, you'll see an increased use of multi-signatures. And the upshot of that is that you'll see less fragility. So right now, you remember earlier in this podcast, we were talking about how I was just like rattled off a whole bunch of things where like if they go wrong, you lose your coins forever. When you introduce multi-signatures into the control of your coins, you are providing redundancy against those. If you lose your keys, you lose all your coins. So rather than having like one set of keys that you like keep under your pillow beside a handgun, you've now got multiple kinds of keys that each independently would all have to be lost, and presumably you would notice as they became compromised. And so now you have that much more redundancy, and your coins are that much more secure, and you have some ability to recover from partial losses of keys. And because this can now be deployed in a way where what hits the blockchain is, again, one key, one signature, you no longer have to pay a penalty for that. So you'll see as a user, both that this stuff is more popular, it's more widely deployed, and also that it's not going to cost you the way that it would cost you today. And then I guess the third thing, of course, is the interoperability that I mentioned. Although that's not necessarily a Taproot thing. That's really just the ecosystem maturing and people working better with each other kind of thing. So as a user, you'll find, it's funny. I mean, you're right. Ultimately, you won't know. It's all like expected stuff, right? You'll see that the software is more robust against various failure modes. You'll see that it's cheaper and more efficient to use. You'll see that there are some new features that exist in various services that you're using. You will also find, although as an end user you won't see this, that privacy is improved by this. And this is something, unfortunately, that's just basically not user visible at all. It's really, really important to Bitcoin to work as a currency and to work as a network, but it's not something that's really user visible. So I guess basically as a user, you'll just see like things just generally get better and more mature, but in ways that wouldn't be happening without Taproot.
Interesting. Right. So what comes after Taproot? What's the next big thing?
So
what are you guys all debating in the background that you want to do next?
So in the short to medium term, one thing that we need after Taproot, or possibly in conjunction with Taproot, is we need a new, what's called the new Sig Hash Mode. This is a very narrow technical thing. We need the ability to sign transactions where we don't necessarily commit in our signature to the exact coins that we're spending. And there's a bit of a controversy about introducing this ability into Bitcoin. It's a bit of a dangerous thing. It means that, well, if I create a signature where I'm not committing to the specific coins that I'm sending, that means that if that signature gets out, if it's floating around the internet, then whenever people send coins to me, if they send coins to the same address as before, somebody will be able to grab that signature and use it to spend those coins. Right? So to have this multiple the signature floating around that can be used multiple times. So that we call it a replay attack. Unfortunately, there are a few other things called replay attacks out there, but this is one example of them. This is a very dangerous thing. Like, why would we want that? There's kind of a controversy about it. The reason that we want it is that in protocols like Lightning, where you have payment channels that are produced where basically two participants, rather than directly sending coins to each other, they put some coin into a pot, and then they repeatedly sign transactions which send the coins to the two users in different proportions. So maybe initially we're sending one coin to me, one coin to you. If I want to give you half a coin, then we change it. So now I'm sending half a coin to me and 1.5 to you. We're sort of adjusting the proportions. And we keep signing new transactions, spending money out of the same pot, signing new transactions that send it to each other in various proportions. And the idea is that eventually we're going to part ways, and then we'll take the final transaction and post that to the blockchain. But until we do, rather than going to the blockchain, why don't we just keep replacing this one transaction and just changing the proportions? And then we don't have to pay the fees. We don't have to take the privacy hit. We don't have to reveal anything to the blockchain. There is a problem with the scheme I just described, where if we have a whole ton of transactions signed that are all spending the same coins, then when we part ways, ideally, only the most recent one would be what gets published to the blockchain. But there's nothing stopping you or I to go back into the past to the giant pile of transactions that we've signed throughout our interaction. Just find whichever one's most beneficial. I'm just going to find whichever one was most beneficial to me and post that to the blockchain. So how do we prevent that? The idea is, or one idea among many, is that when we replace a transaction, we also sign a transaction that sends a bit more money to you than to me. We take the old one that was beneficial to me, and we sign a transaction spending the output of that and giving it all to you. So now if I try to publish this old state, rather than me getting all the coins, or rather than me getting more coins than I should, I publish a transaction that you're immediately able to follow up on where you take all the coins. So I'm not going to do that. So I'll be penalized if I do that. So the idea is now we're still doing the Lightning model where we keep replacing these transactions over and over. But every time we replace a transaction, we make sure that the old one is somehow poisoned. That like if one of us were to publish an old version of the transaction, we would get burned by doing this. And there's a scalability problem here, which is that if every single transaction needs to be poisoned with a new transaction moving the coins to some bad place, If we have, every time we replace, we have to poison the previous transaction, then we're going to wind up with this giant pile of old transactions and this giant pile of poisoning transactions. And it's just going to accumulate on both of our hard drives, and eventually we're going to have a problem. And if we don't want to be online all the time and monitoring each other, if we try to outsource this, then we see that there's an even bigger problem, because you have these entities called watchtowers that are outsourcing all this transaction monitoring and transaction poisoning. And now they have the scalability problem times the number of users that they're being watchtowers for. So one idea is that we could take this thing, this new Sig Hash mode, that lets you sign a transaction but not commit to which coins you're doing, and create one transaction that poisons a lot of old transactions at once. Okay, and you can maybe, I've been speaking a bit abstractly and removing details, but you can almost see how that works, right? Mm-hmm. We have, when we create a new transaction, rather than poisoning just the previous transaction, we sign a transaction that poisons the previous one and everyone that came before it. And so we can just throw out the old poisoning transaction, because we've got an even better one that poisons even more. And so now, rather than having this ever-growing pile of transactions and pile of poisoning transactions, we can now just always have only one that we keep replacing. Right? So we have O1 scalability instead of ON. And that solves, probably the most serious scalability problem in Lightning. So because this is such a dangerous technical tool, like on the technical level, this enables a lot of new ways to lose money if you abuse it that don't exist in Bitcoin today. There's a fair bit of controversy about this, so it might not be deployed at the same time as Taproot. But there are, I think we've kind of narrowed down to just one or two high-level approaches for this. But that's something that the Lightning folks really want, and that a few other people really want. And I would expect that would be the next kind of big change to Bitcoin. So like post-Taproot, that's what we're looking towards. I'm not sure that there's anything else that I can point to and say, like, this is coming next after Taproot or something. There are a lot of different research projects that are very exciting that I think, like, within this decade, we're going to see deployed in Bitcoin. But I can't tell you in what form or in what order or how exactly these are going to shape out, because they're all kind of research and development things. My feeling is that the exciting development in Bitcoin for the next year or two, aside from Taproot, is actually not going to be on the consensus layer. It's not going to require updates, and it's not going to require forks. I think the exciting stuff to watch for are the implementation of these multi-signature schemes that I've been talking about, the deployment of Miniscript, and the ensuing interoperability and ability for users to have complicated spending policies for their own coins. I'm looking forward to continued iteration on just the usual efficiency improvements, better fee estimation, more efficient transaction creation, better privacy technology, more widespread use of things like CoinJoin, and reducing what are called fingerprints when different wallets produce transactions in slightly different ways that identify which wallet is being used or which version of a wallet is being used. All of that stuff is exciting, but to me, what's exciting is all the multi-party transaction, all the innovations in the world of multi-party transactions, where we can do multi-signature, this one key, multiple signatures, and maybe we'll be able to do like Lightning payment channels this way. So I'm thinking a bit here about how there's like super cool things, but the cooler the things get, the more I have to delve into detailed mathematics. And so there's some sort of maximum, I think, in how cool I can sound before I start sounding like a nerd.
Because you love math. That's it, isn't it? I think that was the name of our first show, Bitcoin and Math.
Yeah, right? Yeah, you say, like, what's exciting coming down the line? And I'm like, oh, I'm going to read these 5 books. So on a high level, there are all these different multi-party ways of constructing transactions. I've been talking about multi-signatures, where you have like 5 participants and like all 5 of them interactively cooperate to sign things. There are a bunch of cool variants on this. One is that you can have thresholds, so you have like 3 of the 5 instead of 5 out of 5. That's kind of cool, because if actually any 3 of the 5 participants are able to come together, and they're all using, no matter which 3 you choose, they're all using the same key. But if any 2 of them come together, then they can't do anything. It's kind of surprising mathematically that would be possible. You can do more elaborate things. You can have like any 2 of these 3 participants, or any 3 of these 5 other participants, or just this one guy, or something like that. And you can also encode those kind of policies into a single public key. You can have mechanisms where you add people to the pool, or where you remove. I should be careful. You can't really remove people from the pool without having like everybody delete secret key material, and you can't verify that. But in principle, you can change these policies. You can add new people. You can add new ways of spending. And if you have some sort of deletion mechanism that everybody is willing to trust, then you can also remove different policies. So you can update this without changing the underlying public key, which is exciting. Another really exciting thing is that in the 2-party case, we can, if you're doing a 2 of 2 transaction, you can set up the protocol so that when one party signs, by virtue, or when one party contributes to the final signature, by virtue of contributing to the final signature, they reveal some secret to their counterparty. And this is useful as a building block in things like Lightning, where the idea is you have a lot of different payment channels that are linked to each other, where when one payment channel is updated, the update reveals a secret, like a hash preimage, that can be used to update other payment channels. And so you have like one update that propagates across this whole chain of different payment channels. You can do that just inside the signatures. So now we no longer need script to do these complicated updating, these simultaneous updates of payment channels. You don't need scripts to do atomic swaps, even across multiple blockchains. All these schemes where normally you have the script system enforcing the secret is revealed, you can now do this inside of the signature protocol. And then there are a group of researchers like Pedro Marino Sanchez, Anakit Kate, Giulio Malavolta, a couple other names that I don't have at the top of my mind, who are developing this whole like field of research into what kind of cool protocols you can do in this way, where ultimately what comes out of the protocol and what hits the blockchain is one key, one signature. But what you can do with this sort of becomes much more powerful, much more powerful, certainly, than just one person signing. And one specific cool example, actually, is you can set up, how do I want to say it? You can set up like punitive parts of the protocol. I can do something like, we have our multi-party protocol going on, and imagine you don't want me to sign something. We can set things up so that if I were to sign it, if I were to move the coins in a certain direction, say, by signing a transaction, by revealing that, by doing that signature, I reveal something to you that allows you to do something bad to me or something. So you can introduce like knots, you can introduce negations into these protocols. And so you can have these complicated contracts that are instantiated in these multi-party protocols. And just, like every word I just said there made like academics and people developing stuff cringe, because it's really technically difficult to do this stuff in multi-party protocols. But I mean, this is how research goes. This is how things progress. You can introduce negations into these protocols. And this is really kind of fascinating, because you actually cannot do that with script itself, with Bitcoin script. There is a not operator, but it's not really useful. And let me try to give an illustration of why it's not useful. Imagine that I have coins that say you can spend these coins as long as Andrew signs it, but Peter doesn't. Okay, you can imagine I could write a Bitcoin script just like that says like, you're not allowed to spend these coins. If Peter signs them, they're not removed. Well, that doesn't actually accomplish anything for me to say Peter's not allowed to sign. Because like, even if you do sign, obviously I can just take your signature, remove it, and then publish the resulting transaction. So what does that not clause actually accomplish? The answer is nothing. And the technical word for this is a monotone function. Bitcoin script is able to express monotone functions of different signers and hash primitives and whatever. And what monotone function means is that if it's possible to sign with some group of people, then it is also possible to sign with any larger group of people. Okay? You can't say Andrew can sign, but Andrew and Peter cannot sign. You can't increase the group and then exclude people, because that's just not logically sensible. But when you're doing these interactive protocols, where suddenly people's actions can trigger different events and trigger revealing of different secret data. They might be encryption keys for other transactions. They might be like a component in a zero knowledge proof. They might be other signatures. They might be all this kind of stuff. Suddenly you can do these knots. So now I can have something where maybe I sign this transaction, and if you were to try to sign that transaction, this would reveal some secret that would then allow a third party to just sweep the coins off the table or would somehow invalidate the contract. So this restriction to monotone functions, which is to be clear, this is not a limitation of Bitcoin script. This is just a limitation to things count if you publish them on the blockchain, and they don't count if you don't publish them. Suddenly this limitation, which sort of seems like a really philosophically inherent limitation to the way blockchain contracts work, it seems like we might be able to work around it within these interactive protocols. And that's something that's really exciting to me. And I'm really excited to see how this research develops. And then I have a couple others. Look at that. We're at like 90 minutes, aren't we? I have a couple other related things so I have a hard stop in 40, just so you know. There are other people thinking about multiple transactions. So in particular, I guess you were not at Advancing Bitcoin because you were not in London that week. Unfortunately, I had to go to Bletchley Park without you.
That was when I was in Venezuela. Yeah, because we were going to go and see the machine, weren't we? That I promised to go with you, and I'm really sorry because I really wanted to do that. You're not the only one that wanted to go and see that as well.
Well, definitely next time.
Yeah, definitely next time. I'm sorry about that. Yeah, I was away in Venezuela. I'm sorry about that.
Yeah, no, it was really cool. Actually, I could go like 100 times, and I would never get tired of going. So, right, but at Advancing Bitcoin, James Chang talked about a research project he's doing. Well, it's a bit further than just research that code he's actually writing to model multi-transaction protocols, where you have some setup like a Lightning payment channel or something, where you have a chain of unsigned transactions that all spend each other's outputs, and there are various different paths that these series of transactions might take, depending on how the protocol evolves and depending how people behave. And using Miniscript, James has a way where he can actually enumerate all the different possible paths that coins might move through these series of transactions. But even though you have multiple transactions, each of which individually have scripts on them that control under what conditions the coins can be spent, and you have multiple parties contributing or not contributing to these scripts in various ways, you can get a handle on all of the different ways that things are going to go, and you can actually reason about this and say with confidence, even though I'm chaining 4 transactions in a row, and even though I, as a participant, am doing signatures under these 1,000 different complicated conditions, I can actually enumerate all the different possibilities and be assured that this protocol is secure and it is not going to lose me money. And this is an important thing, because over the years, when I've been talking about all these cool new things we'll be able to do in these complicated multi-party contracts, something I've been sweeping under the rug is that to use this in real life, you have to be able to reason about it, and you have to be able to assure yourself that this stuff is secure. And when I'm talking about things that are on the edge of being able to convince experts that it's even possible, and being able to convince programmers that they understand it well enough to be able to deploy it, arguing that it's secure or that it's robust is much, much harder. So this kind of technology, and I'm going to plug Miniscript again. Miniscript actually makes this possible, where before it wasn't. This kind of research is really exciting to me, because this means that all of these cool ideas that I've been talking about being possible, they start to go from being possible to being real, to being things you can actually envision real people doing on the network. And what's really exciting about this, I think, we're going way back to your original question about what's next, is that this does not require updates to Bitcoin. After Taproot, we get these cool new, all the Taproot benefits. We get Schnorr signatures, which make a lot of this stuff much more efficient. and easier to reason about, and in some cases possible where it wasn't before. After that, we can start building a lot of cool new things that are really novel, that just never existed before, and yet which don't require any updates to the Bitcoin protocol itself, which for validators mean nothing changes. They can still be full nodes. They can still validate all the rules. They don't have to download new updates and learn new rules or anything like that. They just keep on doing what they've always done, and yet the network still gains functionality. So that's what I think you're going to see. I think that's where all the exciting stuff in the next 2, 3, 4, 5 years is going to be, is in stuff like that.
Do you know what, Andrew? You're one of my favorite people to interview, and I never have any idea what you're talking about. I listen along, but I really don't understand it. But I also, at the same time, find it fascinating about all the hard work that goes into this. And I think like it's really commendable, the amount of hard work that goes in, the due diligence that goes in, that everyone puts into ensuring that everything is as smooth as possible to avoid any crazy bugs. I can only say thank you and then apologize for how embarrassing little I understand about it. But I think people are going to listen to this, and the techie ones, the ones who understand Bitcoin, the ones who contribute to the protocol, I think they're going to really enjoy listening to it. For me, I just enjoy catching up with you, mate.
Yeah, no, it's great. Yeah, and thank you. I love talking to you. It's always great to catch up, and yeah, hopefully people listen to it, and hopefully I'm making some sense to somebody.
I think I
but even if not.
Yeah, I pick up a bit here or there. I understand more than I did before, and I did a show with Shinobi about the protocol, and I did a lot of prep, and I definitely know more than I did. But Taproot and Schnorr signatures and all this stuff's another level. But I will listen again, and I will pick up a bit more. I can't see me programming my own wallets just yet, or ever.
Well, you'll get there. No, you'll get there.
Oh, come on, man! I can't program anything. I can design some stuff. Not that.
No, I should not be there. Nobody should be writing their own wallets. I should say. I joke about this, but actually, this is how you lose coins.
Yeah. Well, listen, it is great to catch up with you. I hope you're safe and well in Austin. I don't know when I'll see you next, because I just had this conversation with somebody else, because I don't know when flights will start up again, and I don't know how the world's going to get back to normal. I mean, I would have thought I would see you like every few months with some event or another, or in Austin, but I honestly don't know when we'll get back to traveling. It's a very strange time.
It's hard to say. Absolutely. I mean, I think, conferences and large gatherings are probably going to be one of the last things to start up again.
Yeah.
So, it could be a little while. Yeah.
Well, listen, stay in touch. You're not on Twitter, so I'll have to actually just drop you an email every now and again. But stay in touch, and thank you for doing this, and I wish you all the best, man. Stay safe and stay healthy.
Yep, you too, on all counts. I'll talk to you later.
Okay, so how was that? Did you enjoy that interview with Andrew? Like I said in the intro, if you haven't checked out any of my previous interviews with Andrew, definitely go back and listen to them. They're really good, especially the first one. The first one was a very special interview, one where I turned up prepared with a bunch of questions, and I watched him then do a presentation at the Bitcoin Expo in Boston and realized it was completely useless. So we ran without questions, and we just had this amazing chat. Definitely worth listening to. Now, I normally bump into Andrew at events and conferences a couple of times a year, and when I do bump into him, I pick his brains, I find out what's going on with the tech stuff, what's exciting stuff is coming, and we did catch up in Austin a couple of months ago over some steak, and he promised to come back on the show. But now with the lockdown, I obviously can't see him in person, so we hooked this one up remotely, and even though most of this went over my head, it's always great to get a refresher on what's happening on the tech side of Bitcoin, and also, because I know some of you listeners like the tech, you probably got a lot more from this than I did. Happy to get feedback on this. If you want to hear more from Des, please let me know. You can reach out to me. My email address is hello@whatbitcoindid.com. Also, as I said in the intro, I hope you're all doing okay during this lockdown. I've received so many emails in the last couple of weeks, which is really great. I really do enjoy receiving them, whether it's to discuss topics, it's feedback on shows, or ideas for other shows, and I do reply to everyone. So if you've got ideas, you want to reach out, please do. It's hello@whatbitcoindid.com. If you want some other content, please do check out my other podcast, Defiance, touch some other interesting subjects outside of Bitcoin. I just did an interview with Julian Assange's father, which is fascinating. That's available at defiance.news, and also my films are there. Now listen, stay safe, take care of yourself, be healthy, and I look forward to seeing you all soon.